Hello and welcome to this presentation on lift stations. This is one in a series of presentations on the operation, maintenance, and management of water and wastewater utilities. These presentations have been designed for operators as well as managers of utilities serving Native American tribes and Alaskan Native villages. During this presentation, we're going to review lift stations, their components, how they function, types and models of lift stations and their parts, some emergency provisions, and how operators do repairs or maintain these on a regular basis. So what is a lift station? Well, wastewater lift stations are facilities designed to move wastewater from a lower to higher elevation, generally through pipes. Lift stations are typically located at the low point of a collection system. So you locate lift stations to collect wastewater in a neighborhood or community, large or small community, condominium or apartment complex, for users to connect all by gravity, where sewage flows through a collection system to that low point. And at that low point, you locate your lift station. The lift station can then pump that wastewater or push it from a lower elevation to a higher elevation, delivering it to a centralized treatment plant. There are two common types of lift stations that we'll review in this presentation. There are dry well lift stations and submersible pump lift stations, or wet well lift stations. In a wet well or submersible lift station, pumps, floats, and other parts of the system are located in one vault. In a dry well lift station, there are two vaults used to hold pumps separate from the wastewater. This slide shows an example of a submersible pump lift station with just one wet well. Essentially, this piece of equipment includes wet wells, a couple of pumps, valve vaults, control panels, and alarms. If you follow through the slide with the arrows, you have by gravity wastewater coming in from the collection system in the inlet, filling up the wet well. There are float switches, usually 3, low, medium, and high. You have submersed or submersible pumps, typically 2, duplex pumps. One would run a lead and a lag. When one runs, the other one rests. Those pumps lift the wastewater up through the discharge pipes through your valve vault, where you have valves that you can close one pump or open the other, or vice versa, and then pump it out into the collection system or outlet. Also included as part of this lift station is a control panel and alarm, which are typically located above the ground surface. The system should include an audible and a visual alarm, and allow for shutting off or maintaining pumps and other equipment in your wet well. And this slide shows a wet well with submersible pumps, just a cut view of this type of setup. Again, it shows the wet well, the pumps, your control panel, floats, and it shows the storage volume or the storage vault size. How do you base the storage volume, or how do you determine that size? Well, it's based on the flow or the working volume from your collection system. So you want to size your wet well based on the number of users, and the operator would be familiar with the number of users and be able to assist with the design of a wet well for the appropriate volume. There are 3 volumes shown here on this slide. There's the working volume, which is between your lower pump off float and your upper pump on float. That's the range in which you want the pump to turn on and turn off. Then you've got your sump volume, which is below the pump off, because you never want to run the wet well dry. Pumps do not function well when you run them dry. They tend to break down and need major repair if they're run dry on a regular basis. And then you have your alarm volume, which is above your pump on. If that float fails, then you have a secondary alarm float that comes on, alarms the system, and could have a remote call out. So it's calling an operator, telling them that you have an alarm at a pump station, you have an issue that needs immediate attention. So the storage vault size is based on expected operational requirements for the lift station. The size of the pumps, the working volume, and emergency storage volume. The working volume pumped during each cycle and pump flow should be set to a runtime of approximately 2 to 10 minutes. Shorter, more frequent pump intervals will shorten the life of the pump. And the working volume should be set at a volume that will be dosed at least once per day for smaller flows, because wastewater held in the vault for extended periods of time can become septic, increasing odor and corrosion issues. Here is a quick example of a way to calculate the storage volume of your wet well. And again, The storage volume is primarily needed to determine how long you have until your volume is overcome if there's a clog or an interruption in your system. What formula is used to calculate the storage volume per vertical foot in an 8-foot diameter wet well? In this example, the volume can be calculated using 0.785 multiplied by the diameter squared multiplied by the height. 0.785 is a conversion of pi times the radius squared and typically used by wastewater operators. So in this case, if you multiply 0.785 times the diameter of 8 feet squared multiplied by 1 foot of height, so you get a per vertical foot volume in the wet well, your answer would be 50.2 cubic feet of volume, or converted into gallons, approximately 375 gallons per vertical foot. So if you had this per vertical foot volume determined, you could use a stick to measure the depth of liquid in your wet well and measure the total volume in the wet well for any depth. This also will let an operator know how long it takes the wet well to fill up if the pump fails, and based on pump rates and flow rates, determine how long you have until you have to respond to an emergency before the wet well overflows and contaminates the environment or the low spot in the collection system of someone's house or basement. This slide shows two types of submersible pumps that are most commonly used. Grinder pump, which grinds the wastewater using essentially teeth to grind the wastewater into a slurry before it's pumped out. Then you have submersible effluent lift pumps, which pump the effluent up through the submersible pump without grinding it. It's more of a solids waste lift pump. Both are fairly common and used throughout the United States by tribes and others. The submersible effluent lift pumps have been used more commonly over the last 5 or 10 years, as it's been determined that they generally require less maintenance than the grinder pump. This slide shows a typical example of a submersible lift station installed at a residential multi-unit building. You can see on the left the hatch, the access valve vault, is accessed through that access door. In the middle are two hatches, both to access the pumps or the wet well. This is a wet well setup with one tank. Below grade it was a long rectangular tank because it couldn't be installed very deep because of depth to groundwater being shallow. So as opposed to the example showed in the last slides where it's deeper as opposed to wider, this one is wider than its depth. So the operator can access through each hatch, and the control panel is also shown. You can see the radio antenna, which transfers information back to their SCADA system at their wastewater treatment plant that tells them what type of issue they may have or what type of alarm they may have and whether it needs to be corrected at the site or corrected from the treatment plant. This slide shows the typical components of a lift station. You can see pipe connections, valves, and electrical junction boxes located in the lift station. It's good to locate those things higher in the tank riser so they're easily accessible. On the top end of that lift station, you can see the cables for the floats with extra cable hanging. There are 4 floats in this example. On the right side, there are rails and hoses for the submersible pumps. The pumps can be brought up the rail and thereby maintained by the operator easily without going down into the system. And again, electrical junction boxes should be installed on the high end of the tank so that the operator doesn't have to go into the tank with any regularity. You should periodically inspect wet wells, checking for oil and grease and debris and grit deposits on a regular basis. What is a regular basis? Well, it generally is up to the operator to determine that based on the users. Each lift station is going to have a different user or a different number of users, potentially changing from residential use, commercial, and industrial use. The stronger the waste, the greater amount of oil and grease is going to require more maintenance more frequently. When you're doing your maintenance on these lift stations, pumps, and floats, it's very important to keep a record log of every visit, any number of maintenance activities you've completed, who was there, what the date was, how much liquid was pumped, or the various other details that were completed during the maintenance activity. Why is this important? Well, the record log and the details and the data you've recorded will be valuable anytime down the road for yourself to keep track of this pump station and how it operates, or how it doesn't operate very well and why, as well as passing off that information years down the road or days or months in the future to other operators that may come along when you've since retired. Alright, other things to inspect on a routine basis in lift stations for regular operation and maintenance. Things including alarms. Test them manually. How would you do that? Well, you could open the control panel. You could switch the alarm switch from auto to off to manual or hand to see if your pumps would come on or see if your alarm would go on. You could also test the alarms by lifting the high level float. Open the lift station, put in your stick or hook, lift the float up, and your high level alarm should go off. And confirm that both visual and audible alarms work. This is the same idea for pump operation. If you want to manually operate the pumps, you can do that with the on-off switch or the hand switch, the manual switch, or you can lift the floats to test the pumps manually. When doing this, review the data from flow meters or measure the pressure in your discharge force main. Why would this information be important? Well, you'd want to compare it to your historical data to determine if the pump is operating correctly and pumping the volume as it was designed to pump. Over time, pumps will certainly lose some of their efficiency and not pump the same amount of volume. You want to track that on your record logs that you're keeping every time you go to your system to determine when that pump lacks enough efficiency and doesn't operate correctly and needs replacement. Alright, so this slide we're going to look at other things to inspect on a routine basis, including switching functions. Inspect the floats and again run a manual test. Why is this important? Confirming float operation is important to assuring pump operation and avoiding overflow or pump damage. Make sure their cables are clear of any obstructions while inspecting your floats. Run a manual test. Also, tip the float up and down and be aware of corroding or cracking where the cable meets the float. Because the floats turn up and down so often, there is a chance or a likelihood that that could be a place where the float could corrode or crack at the cable, causing operational malfunctions. Also, record pump run times. Again, longer, less frequent pump times are ideal. You really don't want the pump going on and off every couple of minutes. That will cause a lot of stress on the pump motor. And again, as mentioned before, somewhere between 2 and 10 minute pump run times are ideal. And measure your pump voltage and amperage. A high or a low amperage reading could indicate a problem. What would a high pump amperage reading be indicative of? If you have a high amperage reading, your pump could be working too hard, indicating there might be a downstream clog. In this slide, we'll talk a little bit about grinder pumps. Grinder pumps, again, go in your pump station. They lift the raw wastewater to a collection system. They do this by literally grinding the wastewater into a slurry. This, again, reduces the size of the solids in the wastewater so that they can be discharged as a slurry with no solids into a smaller collection system. This is one of the biggest advantages of a grinder pump system, where you could discharge your slurry into a collection system with a pipe as small as 2 inches in diameter. They could vary from a small to a large horsepower size pump, starting as small as 2 horsepower in a residential setting for a single home, which has been converted from, say, a septic system, single user, to a collection system by pumping with a grinder pump. And again, your wet well for any pump has a short retention time. They're typically between 150 and 350 gallons, including emergency volume. So you want to size your wet well and your pump to evacuate that system in a timely fashion so your wet well does not go septic, creating bigger odor and corrosion issues. In order to assure system reliability, user education and cooperation is a key aspect. Educating your user on what not to send down the drain that could cause problems in your collection system, your wet wells, your lift stations, and your pumps include things like hard solids, plastics, sanitary products, rags, and stringy materials, as well as oil and grease. All of these things can and will clog your system. They'll create more work for your operator staff and ultimately decrease the life of your products and your pumps. Routine cleaning of the vault includes washing down the grinder pump walls, then pumping it out with a vacuum truck or a pumper truck. The reason to do this is that over time you can accumulate grease or oils that will negatively impact the operation of your float switches and pumps. So after you've washed down your grinder pump vault, cleaned off your floats and your pumps and your switches, and refilled the vault, observe pump run times and run them through a full cycle. In a duplex system, confirm that both pumps are turning on and off and alternating. Manually trigger the high water float to confirm that the lag pump will kick on. take voltage readings from the pumps to confirm that they're operating with correct amperage threshold. And again, a high amperage reading can possibly indicate a clog in the pump and or downstream in the valve vault. One of the methods to troubleshoot your system is measuring the scum thickness. You can measure this scum thickness, clean as needed, and keep track of how often it's cleaned using your record log. What this will do is allow you to predict when the next cleaning may be due, because different lift stations are going to have different wastewater constituents and require routine cleaning at different times of year. This slide goes into an example of a dry well lift station. The difference between the wet well and the dry well stations are that dry well stations essentially have two tanks. They have a wet well and a separate dry well vault where the main components are stored. If you follow the red arrows on this slide, you can see the way this system works. You have a collection system coming through the inlet by gravity into your wet well. From the wet well, the pumps draw the effluent into the dry well through the valves into the pumps and discharge it into the collection system. You can open and close the valve before each pump. These are duplex pumps and they run lead lag, just like the wet well. This setup is to allow regular access by the operator. Maintenance is conducted inside the dry well, as opposed to the wet well where pumps are lifted out and maintained. For this reason, the dry well must be adequately ventilated. The ventilation is important for maintaining cool temperatures during pump operation as well. So the dry well needs adequate space for all these components and should have a floor drain or sump pump because, as we all know, pumps and valves leak occasionally. The dry well lift station has a wet well that's sized the same as a wet well. When it stands alone, it has a working volume, an emergency storage volume, and a sump volume. There are float switches to have pump on and off and create alarms as needed. An advantage of the dry well lift station is the operator gets in and out, and it's a dry well, there's no contact with wastewater, allowing for easy access for routine visual pump inspection. The downside of a dry well system is there are two tanks requiring more space, thereby costing more money. Over the last 10 years, newer pumps have been constructed to work well submerged in a wet well, and this has become the most typical way to create a pump lift station. This slide shows a typical arrangement of control panel or alarm systems. These panels and systems can be ground mounted or mounted on the side of a building and typically include an enclosed panel. In the panel are breakers or fuses for operating your pumps or your floats and switches. It can include a PLC or programmed logical controller, so the operator can manually control or maintain the pumps, floats, and other electronic equipment. On the top of the panel is a high water alarm and has a visual and audible display on the top of the panel. Both should always be included on an alarm system. And as mentioned, some of these systems can connect to an auto dialer through a PLC system to alert the operator of an alarm, because operators' jobs are typically 24/7 as someone needs to respond to an emergency wastewater situation. These control panels should be locked, only accessible by authorized personnel. Below the control panel in the middle, you can see an outlet. We'll discuss the outlet as it relates to generators and emergency response scenarios. The panel should also include on the front a label with some contact information, and again, the residences or the users should be educated as to what these panels are, what they mean when the alarm's going off, and who to call in the case of an emergency. Again, in this slide we're talking about emergency response and emergency operating procedures, what you do in the case of a high-level alarm. Well, first you should educate the community so these folks know who to call and what to do when their alarm goes off. You should be able to have a quick response to backups or alarms. 4 to 6 hours typically is the maximum response time, but again, the response time depends on the emergency storage volume in the wet well. Again, understating the operator's knowledge of their system and each wet well and how much volume it can store before it discharges to the environment or the user's property. As mentioned before, you could provide additional storage in the wet well for short-term power outages or pump failures. You should have multiple pumps at each lift station, alternating in normal operating conditions, and ideally have a pump at your shop on the shelf that matches the ones in the wet well so that can be replaced immediately and you don't leave your wet well running on one pump for any extended period of time. In this slide we're looking at emergency power. It can be provided by a portable emergency generator able to provide power during extended power outages. And during design or before purchasing this type of emergency generator, confirm that the electrical adapter for connection to the generator to your control panel are compatible. This type of portable generator could be stored at the site or at a main location at the shop so the operator can access it and use it in case of emergency or emergency situations. Emergency power can also be provided by a generator located on site. Most lift stations should have a generator located on site or some other backup power located nearby. Even though there's an emergency, wastewater doesn't stop flowing, pump systems can be overcome very quickly, and if there isn't sufficient overflow storage, then emergency power should be provided. An ATS or auto transfer switch. This switch comes on in general if there's a power surge or lack of power. So not only if the power goes out does the switch turn on the generator, but if there is a 10% or more drop in power. These standby emergency generators need to be exercised. They should be exercised weekly at a minimum. At that time, there should be a record log kept of what date, time, and the operator that tested it, as well as the runtime and the results of that runtime. Generator operation and testing can be done by the operator if the operator feels they have the experience to do so. Otherwise, this work should be subcontracted out to a subcontractor that has experience running and operating generators. In the case of a pump failure and emergency power cannot be accessed immediately, what would you do for next steps? Well, you could call the local septic tank pump truck owner, have them come down and pump out your wet well. That's not inexpensive, and that can cost you hundreds and thousands of dollars depending on the size of your wet well. If you're doing it on a regular basis, it can hurt your overall budget. Another potential option on the slide here on the right is a small track-mounted pump. Having that on hand for failures, it's a capital cost upfront investment, but over time will pay for itself when responding to these types of events. Basically, this is a trash pump with a small tank where the hose is dropped into the wet well, and the trash pump pumps the contents of the wet well up out of the wet well and can be connected to a bypass valve that can be installed downstream of your wet well and discharged into your collection system. This adjustment can be made at any time, and the installation of a bypass valve and the use of this track-mounted system can save the operator money in the long run. Now we'll just discuss briefly some safety and potential hazard steps that can be taken. What is confined space, and what areas are classified as confined space? Policies and procedures may vary by agency, and they should be known by all operators, confirmed with management, and followed. Exposure to gases can be lethal. Wastewater is dangerous. A wastewater system operator has more hazards than a water system operator, and entering confined spaces should be done carefully with proper training. Proper training should include how to operate a multimeter or a portable gas meter. If you're entering a confined space or opening a hatch to one and you have hydrogen sulfide rotten egg smell, do not go in without proper training and following these policies and procedures. Beware of electrical safety and potential hazards with electronics. Be sure to have lockout, tagout procedures in place. If a pump's turned off and you're operating and maintaining a pump or a wet well system, be sure to lock it out and tag it out and date it prior to doing any maintenance on your pumps or floats in the wet well. Again, wastewater is not clean. Be aware of hygiene and washing your hands and exposure to wastewater and cleaning up subsequent to working on any equipment. Always have the appropriate personal protective equipment, gloves, glasses, and other safety devices and items needed to stay safe. With safety and accessing a wet well, a minimum of 2 trained employees for service calls should be used, and access to a lift or pump service that requires pump removal is necessary. These photos show good examples of maintenance workers with the correct setup, the correct personal protective equipment. On the bottom slide, the workers are using a tripod to enter and exit a subsurface confined space. They have a tube and a vent for ventilation. So following safety procedures is important. And a question for operators. If your coworker goes down or is injured inside the confined space while you're watching it from above, what would you do? Well, the answer everyone should have is don't go in after them. What happens invariably in this case is a tragedy can strike 2 people as opposed to 1. causing 2 fatalities instead of 1.
The person should immediately call for help and wait for that help to arrive before proceeding with any activities down in the hole.
Over the next couple slides, we'll go over some troubleshooting for pumps, potential issues, symptoms, and how to respond to those. If you have pumps in your wet well and they're not operating, the symptom would be, or could be, that this is a wastewater backup. So you've got too much wastewater in your wet well. What would you do first? First, check the power supply. Go to the control panel, open up the panel, see if your breakers are on, or if your fuses are good, or if they need to be replaced. If you go to control panel and your fuses are good and your breakers are on, open up your wet well and take a look inside. Confirm that the high water level exists in the wet well. You've gotten an alarm that says you have a high water level. By checking the power, you know that the power's on. Now you've opened the wet well and confirmed that the actual condition exists. If the wet well's full, you could manually trigger the pump to lower the liquid level, or use a portable pump to lower the liquid level. Now that you've lowered the water level, you can inspect the pump. The liquid level should be lowered to a point within the operating levels of the pump. Don't pump the wet well dry. Then you can pull the pump up the rail after you've shut down the power and locked out and tagged out the power at the control panel. So you've confirmed that the high water condition exists, the breakers aren't tripped, and the fuses aren't broken, so observe that the power supply is on and working. You can do this by checking the amperage drawn by the pump, using a portable electrical amperage meter. So in this example of how to troubleshoot your pumps or your wet well system, we have a high level condition, and the symptom is that your pump is running on auto, but the liquid high level remains high. In this case, your pump is pumping, it should be discharging wastewater into your collection system, but the pump is running, the liquid level remains high. What kind of procedures or what kind of steps would you take to resolve this situation? Well, there could be a blockage at the pump intake. The pump motor would continue to run, even though there's a block at the intake. Check your filters and screens to make sure they're not clogged, and pump down the wet well to normal operating levels with the other pump or a portable pump. If in this case you've pumped down the wet well and your pump is still running as if there's a high level condition, what other issues may be causing this condition? You should inspect the valves, as in this photo example on the top right. Make sure the valve's open and it's seated correctly. There's not a blockage in the valve or it's not partially closed. If you do have a blockage in the discharge, your pump is still running, it's deadheading against the blockage. This is not good for your pump and will reduce the life of the pump ultimately. It could be an old valve that's just not able to open full anymore. Again, if you've got a record of when this valve was installed, possibly the last time it was maintained, you can determine its age and whether the age may be an issue. Or if you live in a cold weather climate, you could have a frozen pipe that's not allowing your system to discharge. Another potential cause for a high level alarm or continual high level alarms in a wet well could be infiltration into that wet well. It's possible that your wet well is cracked, you have a high groundwater condition, you have infiltration into that wet well through a crack or through a seal. It could also be the case that your check valve is broken. If your pump is pumping wastewater out of the wet well into your collection system and your check valve is broken, when that pump shuts off, that wastewater could run right back down by gravity through your check valve and into your wet well again. Another example of how to troubleshoot a wet well, if you have the case of a low level in your wet well and your pumps are running on auto without shutting off, what could be the potential issue here? Well, you can check the position of the wet well controls, meaning the floats. If the float's gotten stuck or tangled somehow in an on position, causing the pumps to keep running even though the level in the wet well is low enough that they shouldn't be. If that's not the case, then a pump starter contactor could be stuck closed, making the pump run constantly. In order to make that repair, if you as an operator feel capable and comfortable doing so, turn that main power off, following all lockout and tagout procedures. Determine if that motor starter relay is operating properly. Contactor could also be closed due to corrosion, moisture, or insect if the pump is old and hasn't been maintained properly. And then if you find that it is the case that that relay is broken, replace that relay if necessary yourself or send the pump out to the manufacturer for maintenance. If you have a low level alarm, check that the wet well is not leaking. As you can see from the picture in the top right of the presentation screen, control panels can become corroded over time due to lack of maintenance, leaking water, or infestation of bugs. All of these things can result in operational system issues. So periodic maintenance of the system should include cleaning any dirt or debris from the control panel and replacing any components that have been damaged from corrosion. Another potential issue with wet well systems and check valves and troubleshooting those, is it the case that your pumps are running frequently, and what might potentially cause that? Well, are the check valves on the discharge force main seated correctly? Are these valves aging and unable to be closed or opened all the way? Make sure that the check valves close when the pressure drops such that they don't allow the wastewater to flow back into the wet well. If these check valves don't close, the wastewater that's pumped out of the wet well through the valve vault into the force main is going to come back through the force main
by gravity into the wet well because it's the low point of the system. This concludes our presentation on wastewater lift stations. We've discussed the types of lift stations, both submersible and dry well lift stations, common components of lift stations, including grinder pumps, submersible pumps, and some of the common operation and maintenance practices. We've also reviewed a few ways to potentially troubleshoot problems with lift stations that you may experience as an operator on a daily basis. Thank you for participating in this presentation, and I encourage you, if interested, to investigate some of the other water and wastewater system operation and maintenance presentations that are part of this training series.